Today we're looking at lesson 6.3, the second day, mapping transformations. So yesterday we looked at rotations and translations. Today we'll be looking at reflections. So we have the same objective as we had before. Given a point and a rigid transformation, I can write the coordinates of the image in 3 out of 3 problems. Now just a quick overview of the definitions we came up with yesterday. We had a translation, which was moving every point of a figure by the same distance in a given direction. And remember, we had these vectors that said we moved a particular length and a particular direction. Each of the points moved the same length, same direction. Then we also had a rotation, which is a transformation that moves every point of a figure in the same direction, either clockwise or counterclockwise, by the same rotation angle around a fixed center. Remember, this was kind of a fancy way of talking about circles that were all centered at the same place. Each of these points moves according to a concentric circle. That means with the same center. So today we are going to add onto that the rigid transformation of reflections. Now, what is a reflection? How would you describe what a reflection is? We've got a picture of it up there in the corner. Pause the video for a second, jot down a few ideas on how you would describe what a reflection is. So now that you've thought a little bit about how you would describe a reflection, let's see what our definition is. A reflection is a transformation that moves each point in a figure the same distance from the line of reflection. So here we had a point, here's its reflected image over here. And we move it the same distance from the line of reflection. You can see it's the same distance away. But we have maybe a little bit of confusion with this definition, because here we have a line of reflection, here we have a point, and we could actually draw a lot of different distances, couldn't we? Could we draw a distance there, maybe a distance there, maybe one over here, one right here. Which one of these distances should we use? Because if we're going to draw a reflection the same distance away, it kind of matters which one of these distances we use, right? That would mean that that would be a reflection, and that would be a reflection, and all of these would be a reflection. But there's really only one reflection over a line, so we need to know which one to use. So which one of these lines do you think we should use? We've got AB. Remember, we have this syntax for writing a line segment, AB. We have AC, AD, and AE. All of these are options of distance between A and the line of reflection. But which one of these lines should we use for the reflection itself? If you chose line AC, that's the correct one. And we know that's the correct line because it has that 90-degree angle. That's the closest distance because it's the 90-degree angle. And we always use the perpendicular line, the 90-degree angle, when we're doing reflections. So another way to describe this is lines that join corresponding points are bisected perpendicularly by the line of reflection. The line of reflection serves as a perpendicular bisector. Now those words, perpendicular, that's one of our vocabulary words. Bisector we haven't talked about before, but if we take that word apart, what that means, bi means to, sect means to cut, And so what bisector means is to cut into 2 pieces, or more specifically, to cut into 2 even pieces. So that's saying it's going down the middle of this line segment, which makes sense because we said this side is equal to this side, right? So this is the middle of this whole thing. So this line of reflection is the perpendicular bisector of the line segments between corresponding points, between reflected points. So remind me again, what do we know about perpendicular lines? Specifically, what do we know about the slopes of perpendicular lines? Do you remember? We learned it a couple of lessons ago. We talked about perpendicular lines having opposite reciprocal slopes. Remember, those words mean plus or minus. We change the negativity of it. And then reciprocal means we flip the fraction upside down. So if it was like 1/3, we'd flip it to 3/1. So perpendicular lines have opposite reciprocal slopes. We're going to use that information to find the reflection of a point. So here's how we're going to do it. These are our steps. The first thing we do is we find the slope of the line of reflection. We can either do that on a graph, or we can use the equation, the y equals mx plus b, right? Our m value is going to be our slope. Then our second step is to find the perpendicular slope, and this is the symbol for perpendicular. And we use that opposite reciprocal fact, reciprocal. And we find the opposite reciprocal of the slope of the line of reflection. That means we now have the slope that connects the 2 points. And our final step is to use that perpendicular slope to go the same distance on the other side of the line. So let's see this in action. Let's see how we do this. We're going to reflect point A over the line of reflection. So here's point A over the line. Point A is at 1, 1, and our line here is y equals x plus 4. You can see there's our y-intercept at 4. Our slope is up 1/1, so our slope is 1. You could also see that up here in the equation, there's kind of an invisible 1 in front of the x. That's our m in mx plus b. So that's our step 1 already. Step 1, our slope of the line of reflection is 1. Step 2, we're going to find the perpendicular slope. Perpendicular slope is, well, we'll take the opposite, so the negative, and then we're going to flip it upside down. So if we wrote this as 1/1, upside down, it is still 1/1. So our perpendicular slope is now negative 1/1. That means we'll go down 1 and right 1, or we could go up 1 and left 1. So let's go that direction. Let's go up 1 and left 1. Up 1, left 1, because that's going toward the line of reflection. Up 1 and left 1. And you can see right there is where we meet the line of reflection. That means we did 2 full slope steps. 1 full slope step, 2 full slope steps. We'll need to do 2 on the other side for it to be the same distance away. So we'll just keep going on the same slope. 1, there's 1, and then 2. And that is where our image lands. A prime. This is the point, -3 is our x, 5 is our y. So those are the coordinates of A prime, -3, 5. Notice if we draw this perpendicular line here, if we draw this line that goes from A to A prime, it is in fact perpendicular to that line of reflection. We confirmed that would be the case by following these steps, finding the slope and then finding the perpendicular slope. So that's an example of how we find the reflection of a particular point over a line. Let's try another example. Here we go. Reflect point B over the line of reflection. Point B is -4, -1, down here, -4, -1. And our line of reflection is -1/3 x plus 1. So we have a y-intercept of 1, and we go down 1 over 1, 2, 3. That's a slope of -1/3. So that answers our first step already. Our slope of our line of reflection is -1/3. You can also see that up here in the equation. That's the m in the mx plus b. So our slope is -1/3. Our second step is to find the perpendicular slope. A negative of a negative is a positive. And then flip this upside down, we get 3 over 1. That's going to be a rise of 3, a run of 1. So now we'll start at B, and we're going to follow that slope, rise of 3, run of 1. We're going to go toward the line of reflection. So rise of 1, 2, 3, run of 1. And we run into the line of reflection right there. So that was one slope step. That means we need to go one slope step on the other side. 1, 2, 3, and run of 1. So that's one slope step over here. That leaves us at our image, B prime. So our coordinates here are -2, +5. Those are the coordinates of the image of B prime, or sorry, the image of B, which is B prime, over the line of reflection. Once again, if we draw this line, that's pretty close to the line from B to B prime, you'll see it is a perpendicular line. It does form a right angle with the line of reflection. All right, go ahead and try this one on your own. We have point C, we want to reflect it over the line. Give this one a try, see if we come up with the same answer. So pause the video, try to do this one on your own, come back, see what we get. All right, so our first step, we are going to find the slope of the line of reflection. Now we have the line listed up here. We can also look on the graph. You can see if we start at this point, we'd go up 1, 2 over 1. That would get us between those 2 points. So that's a rise of 2, run of 1. Rise of 2 over the run of 1. And we can also see that in our equation up there. Our slope is 2, which we could also think of as 2 over 1. We find the perpendicular slope, which is the negative and flipped upside down, -1/2, the opposite reciprocal. And now we're going to follow this perpendicular slope down to the line of reflection. So -1/2 would go down and right. We go down 1, right 1, 2. So this was our rise of -1, run of 2. We went down 1, run 1, 2. Found a dot there. This is where we run into the line of reflection, so that's one slope step. We're going to do that one more time. Down 1, over 1, 2, and put a dot there. This is our slope step on the other side, so that's going to be the location of our image, C prime. That is at 3, 0. Once again, if we draw this line between the point and its image, that is a 90-degree angle. It's a perpendicular line. So that wraps up reflections and all 3 rigid transformations we're looking at. Translations, rotations, reflections. Here are the 3 definitions again. These might be handy for your notes if you ever just want to refer back and see what each of these rigid transformations is defined as, how it works. And that wraps up everything for this lesson. Given a point and a rigid transformation, I can write the coordinates of the image in 3 out of 3 problems.